Welcome to another video. This time we're going to have a look at measures of location and spread. So this is in the chapter 2 section of the Statistics and Mechanics book of the Year 12 course. So if you're watching now and thinking this is the first of the videos in terms of order for stats and mechanics, you may be wondering, why are we not starting with chapter 1? Well, at the moment, things might change in the future. My plan would be that chapter 1 should be best done as independent reading for you to do on your own. So chapter 1 is important, but it is a rather dry chapter filled with many definitions and things that just need to be almost learned off heart without as much application as in chapter 2. So it's not going to be as dynamic, which isn't to say it's not as important. So if you could have a look at chapter 1 yourself for independent study, that would be ideal. Chapter 2, we're going to pick up with measures of location and spread. A measure of location is, for example, the mean, the median, and spread, we're going to see here, is, for example, the range, interquartile range, and also the standard deviation. And so it's what you may have seen at GCSE already, but dare I say, in a bit more depth. So this lesson, chapter 2.1, is going to be a grounding session, pretty much just recapping from GCSE, but then in chapter 2.2 onwards, the difficulty and complexity does ramp up. So let's start off now with the warm-up questions. So here they are, 4 as there normally is 4. Try them yourselves, press play now, sorry, press pause now I mean to say, then press play when you're ready to see my solutions, and then you can see your answers versus mine and make any corrections where necessary. Okay, so let's have a look at question 1. So for question 1, we're asked to calculate the mean, median, mode and range for this following set of data. So I'm sure you know this already. If not, it should come back very quickly. So the mean is going to be the sum of all the values divided by the number of values we're adding together. So the mean is going to be just simply 3 plus 5 plus 6, add the 2 7s, plus 9 plus 11 plus 16. And we've got here 1, 2, 3, 4, 5, 6, 7, 8 values. So we're going to divide that by 8. So if we get our class whiz ready, and make sure we're in the correct mode, so mode 1. I'll show you about statistics mode later on in the video, in fact. So add all these values together. We've got 3 plus 5 plus 6 plus 7 plus 7 plus 9 plus 11 plus 16. Make sure this is in brackets or press equals first before dividing. Then divide by 8. You should find that the mean for this data set is 8. The median. So we need to be thinking what the middle value is. So working from end to end, it's not the end ones, nor those, nor those. So we've got 2 values in the middle. So you should recall that the median, if you have 2 numbers in the middle, is the mean of the 2 numbers that are in the middle. But because we're both 7, we can just say that the median is just simply 7. Similarly, because there's one of each data value apart from the 7s, the mode is also 7. If you recall from GCSE, mode is the most common value. So there's 2 7s, only one of anything else, so the 7 is most common. And the range is the highest subtract the lowest. So in our case, the highest value, the greatest value is 16, the lowest is 3. So we have 16 minus 3, which gives us 13. So that's all there is for question 1. So now have a look at question 2. So question 2, we've got here a matching activity. So we've got the mean, median, mode and range. So we need to match the following statements to the correct statistic. So first of all, the mean. So which one does the mean match to? So let's just think of it slightly carefully. So the mean is always going to involve all data points. So the mean always uses all the data points. We add up all the data and then divide by the number of data points we have. As well as that, the mean is affected by extreme values. For example, because a mean uses all values, if one is very high or very low, that affects the whole thing. And also as well, the mean is sometimes referred to as simply the average. So if a question just asks you to work out the average without specifying which average it is, mean, median or range, we can always assume they must want you to work out the mean. So next up, let's be thinking of the median. So the median is going to always be unaffected by extreme values. It only considers the middle ones. So it's never going to be affected by the ones on the extreme high or extreme low side. As well as that, the median, let's see if there's anything else for the median. In fact, I don't think there is. So that's all we need to do for the median. Next I'll look at another one. So let's have a look now at the mode. So the mode, weirdly, might not actually exist for some data sets. The mode is the most common value, and so for example, if we're just one of each value, you have say 10 values, the mode would be meaningless because you'd have 10 modes. So normally, there's either one mode, sometimes there might be two modes. Any more than that, it's a pretty meaningless statistic to take. So as I said, because you could have two modes, sometimes you could have two values for some data sets. And so the mode could be two values for some. And as well as that, the mode will always be a value itself within any data set. So for example, the mean may not be in the data set. The median might be or might not be. For example, if there's two values in the middle of a data set, we take the mean of those, so it might be halfway between two existing values. So the median may not exist itself within the data set. So the mode always will, however. And finally, just looking at the range. So the range, strictly speaking, is a measure of consistency. The smaller the range, the more consistent the data is. And so finally we finish off by saying that the range is a measure of consistency for the data. Let's just make sure all are matched up. They are. So that's question 2 complete. Question 3, Rosie has 10 boxes of drawing pins. So she counted the number of drawing pins in each box. She must be rather bored, is all I can imagine. The table gives some information about her results. And here they are in the table. So we're tasked with calculating the mean number of drawing pins in a box. So this is very much a GCSE question. And what GCSE teacher may have told you is to label this one x times f. And so this may be written as fx. Another teacher might just say just multiply these two columns together and put your answer in here. So that's all we need to do. So I'm going to explain why we do that, just to remind you from GCSE. And so two boxes had 29 drawing pins in them. So the total drawing pins in these two boxes would be 2 lots of 29, and use your calculator here, would be 58. 5 boxes had 30 pins. So 5 times 30, that's 150 pins. 2 boxes had 31. So 31 times 2 is 62 pins. So just add this in here as well. 31 times 2 is 62. And 32 times 1 is obviously going to be 32. So now with our class words, we need to add all these values up together. So 58 plus 150 plus 62 plus 32. That gives us 302. So at this point, it's going to just do a totals column for frequency and fx. So frequency, we're told there's 10 boxes, so that's 10 boxes. And then fx, add all these together, we get 302. So in calculate the mean number of drawing pins in a box, the mean is just going to be 302 divided by 10, which gives us 30.2 pence. Lastly, question 4. We've got 80 people working in Jenny's factory. The table shows some information about the annual pay of these 80 workers. Again, this is very much a GCSE question, so we're told to calculate an estimate for the annual mean pay. So what you might remember we need to do here is to take midpoints as an estimate. And so what we need here is 2 extra columns would be what I'd suggest, until you get to grips with the class whiz, but I'm going to mention that later on. So we take midpoints because for these first 32 workers, there's no telling if they earn 10,500, 13,000, 11,000. So essentially we need to take our best guess of the wage of a typical average worker in this group. So your best guess is going to be the midpoint. Sure, some might be earning less than the midpoint and some might be earning more than the midpoint, but the idea is if you take the midpoint, chances are more or less it'll average itself out, with people a bit higher and a bit lower, making it fairly standard. So here we've got 10,000 and there's 14,000. So the midpoint of these is going to be 12,000. So we go down similarly here. So 14,000 to 16,000, for midpoints of those, that's going to be 15,000. Between 16 and 18, the midpoint of those is going to be 17,000. 18 and 20, midpoint's 19,000. And the last one, a much wider class width, from 20 to 40, add them together you get 60, divide by 2, you should find the midpoint there is 30,000. Once you've got these midpoints, we then multiply the midpoints by the frequencies for each row. So just simply multiply. Afterwards, we're going to add up to get our totals. So first of all, 32 times 12,000. We'll move this here so we can see what we're doing. So 32 times 12,000, let's see what this gives us. Going to be some big numbers here. We're going to get 384,000. The next one, 24 times 15,000. Let's see what that gives us. So 24 times 15. 360,000. The next one, 16 times 17,000. Always check with a calculator, just so you're not making any silly slips. So 272,000 here. 6 times 19,000. Gives us 114,000. And finally, only one more row to do. So finally, 2 times 30,000. I'm pretty sure we can do this without a calculator. 2 times 30,000. That's 60,000. Now again, do totals. So again, we're told that 80 people work in her factory. So this here, total number is going to be 80. And the total of all these values here, we add up the total of the midpoint and frequencies. You don't do the total midpoints, because that's going to give us meaningless information. So we just total up these values here. So we've got 114,000. So then we can add 60,000 to that. Oops, got a bit crazy there. So 114,000, then plus 60,000. Now plus 272,000, plus 360,000, and finally the last one at the top, plus 384,000. So you should find that the total here comes to 1,190,000. And so now we just take these totals here, the total of the midpoint of the frequency and the total of the number of workers, which is 80. And we use these to calculate our estimate of the mean. So the mean is going to be 1,190,000. Divide that by 80. So just to remind you where we get these numbers from, I'll just highlight them. And then we'll see that the mean wage is £14,875 a year. And that's for warm-up questions done. So let's have a look at what's in store today. So we're going to begin with looking at measures of central tendency. So just talking you through this step by step. A measure of location is a single value which describes a position in a data set. So if the single value describes the center of data, it's called a measure of central tendency. And there are three main measures of central tendency you should already know from GCSE, and these are the mean, the median, and the mode. You should as well already know how to work out the mean, median, and mode of a set of ungrouped data and from ungrouped frequency tables. So generally speaking, if we have n data values in a set, the mean, which is denoted as x bar, can be calculated using the below formula. X bar is sigma x, which means the sum of all the data points, divided by n, where n, as we've said, is the number of data values in the set. The median is the middle value when the data values are put in order of size. If there are two values in the middle, then the median is the mean of these two values in the middle. The mode, sometimes called modal class, is the value or class that occurs most often. So in terms of modal class, it's the class interval that has the most items inside it. That would be the most obvious way of me putting that one. So now, let's have a look at a worked example of actually calculating the mean, which is done in a slightly trickier way, but I'm sure with a bit of practice we'll find these questions absolutely straightforward. So we're told here we've got a mean of a sample of 25 observations, which is 6.4. Then we've got a mean of a second sample of 30, is 7.2. Then we need to calculate the mean of all 55. So because it's split into two, the sample of 25 and the sample of 30, we need to consider this as two separate calculations to begin with. So let's consider first of all the sample of 25 observations having a mean of 6.4. So I'm going to call this mean for group 1. So the mean of group 1, or for sample 1, I'm going to put subscript 1 here. Remember, we calculate the mean by taking the total of all values, so the total of group 1, divided by the frequency, how many items are in the group. So again, I'm going to call this group 1 as well. So substituting in what we know, we're told the mean is 25 for this one. No, we're not. Wake up. Sorry, we're told the mean is 6.4. Okay, we're not told the total. So we leave this as total 1. However, we are told that we have 25 observations. So the frequency for this first group is 25. So therefore the total for group 1, if we just rearrange this, we'd have 6.4 multiplied by 25, which gives us 160. So that's for the first group. We now do the same process for this second group. So we're told for the second group that it's 30 observations with a mean of 7.2. So the mean for group 2 is again the total of the data values for group 2 divided by the frequency for total of items, or observations in this case. in group 2. So if we just substitute in what we know, we're told the mean here is 7.2. So that's going to be the total of the values here, which again we're not told. But we are told that this one has 30 observations in it. So again, with a simple rearrangement, we can find out the total for group 2. It's going to be 7.2 multiplied by 30, and 7.2 multiplied by 30. Check on a calculator if you'd like. That should give you 216. So, next up, we need to calculate the mean of all 55 observations. Sorry there, the mean of all 55 observations. So now, the overall mean could be considered as so the overall mean is going to be the grand total of all of these data points I'm going to divide that by the total frequency. So we're told what the total frequency is. Total frequency, we're told there's 55 observations. We could have done 25 plus 30 as well, of course. But the total frequency is 55. And the grand total for all these observations is 160 plus 216. And so now if we try this on the calculator, so 160 plus 216, and divide that by 55, we get here to 3 significant figures, but the mean is going to be 6.84. And that's all there is to do for this first example. Before we look at a second example, it's just now worth recapping a few things from GCSE in terms of calculating statistics, in particular the mean, from frequency tables. And so on that note, it's worth just me sharing this information with you. So, for data given in a frequency table, the mean, x bar, can be calculated using the formula below. So x bar, which just is how the mean is written, is sigma xf divided by sigma f. So sigma xf just means the sum of the products of the data values and their frequencies. So sigma, this symbol here, will always mean sum of whatever follows. And sigma f just means the total of all the frequencies combined to give the overall frequency of the whole data set. So here's a worked example now, based on what I've just mentioned. So we've got Rebecca here recording the shirts and the collar sizes of the shirts of male students in her year. So the results are shown in this table here. So we've got 4 things to work out based on this data, and the first thing we need to calculate is the mode. So mode just means most common value. So this one is, for my money, the easiest thing to do. Most common value is going to be the one with the greatest frequency. So 3 is probably the least popular. 34, this one here, is the most popular shirt size. 34 students had a shirt size of 16.5, which is more than any other group. So for that reason, the mode is 16.5. For part B, looking at the median, we just need to recall that the median is the middle value. Now, I'm going to share a strategy for calculating this without getting too confused by it. What we're going to do, we're going to have a look at the number of students here and do a cumulative frequency column, where we're going to do a running total of the sum of these rows. So the first row just has 3. The next one, 3 plus 17, is 20. 20 plus 29 is 49. 49 plus 34, that's going to give us 83. And finally, 83 plus 12 is 95. So we've got 95 values. So if they're in order, for median, we do this by taking the number of values, adding 1, and halving it. It'll be that number value. So 95 plus 1 is 96. Divide by 2 means we're after the 48th value. So how does what we've done help us here? Well, what we do using this cumulative frequency column is we go down and stop as soon as we see a number which exceeds the position of the median. So we stop when we get to a number which exceeds 48. 3 is too small, 20 is too small. The first number that is bigger than 48 or equal to 48 is 49. So for that reason, we read across and see that the median shirt collar size must be 16. So therefore, the median in this case is simply 16. Part C, we need to work out the mean. So we can clear off what we've done here. This cumulative frequency is now served its purpose, so I'm just going to get rid of this. Now this goes back to what I said about the fx column. It was written xf, but it's the same difference. So if I just put xf here, which is the same as fx, all we're going to do is we're going to multiply the shirt collar sizes by the number of students each time. And then we're going to total them up as one of the last steps. So first of all, 15 times 3, that's going to give us 45. Generally speaking, safest use a calculator. So the next one's 15.5 multiplied by 17. So 15.5 times 17, that gives us 263.5. So we write this down as well. Next one, 16 multiplied by 29. So 16 times 29, that's going to give us 464. Then the next one is 16.5 multiplied by 34. So we type this in next. So 16.5, oops, I've got the decimal, multiplied by 34. That gives us 561. And now last but not least, we're going to do 17 multiplied by 12. So 17 times 12 gives us 204. What we're going to do now is we're going to total up the frequencies and the xf, which is the same as fx. So if you add all of these up, we did this for part B, for 95 values. So the total number of values is 95. And if you add all these values up for the xf, so we've got 204, so plus 561, plus 464, plus 263, whoops, 263.5, plus 45, that should give us 1537.5. So now we've got all we need to calculate the mean. So using this formula from before, the mean is sigma xf divided by sigma f, which is 1537.5 divided by 95. So if we just pop these numbers into our calculator, we'll move this out of the way so you can see. So divide by 95, that's going to give us 3 sig figs, 16.2 inches. Didn't underline part A, so that's going to feel left out if I don't do that. Okay, I'm going to show you now how to do this using the class whiz. So, how can we do this in a simpler way? Well, I'm going to let you into a little secret here. So, what we do first of all is we just press menu. So, press menu and we scroll along until we get to statistics. So, press menu and then equals when you scroll to statistics. So, press equals. Here we've got one variable, for one variable being the shirt collar size. So, press option 1 for one variable. We now have, as you can see, a table we can fill in. But you might notice that there's no space to input the frequencies. But don't worry, I'm going to show you how to do this as well. So to make a space where we can input the frequencies as well, what we do is you press Shift, Menu. Now we scroll down until we see Statistics. So option 3 for Statistics, press it. And frequency, press 1 to turn on the frequency column. So press 1, and there we have frequency as well. So where it says X, we're going to input the shirt collar sizes. So 15, press equals to go to the next one, 15.5, 16, 16.5, and finally 17. When you put in all the X values you wish for, just scroll along, press right, and toggle up to go to the top, and then input the frequencies. So 15 had a frequency of 3, press equals. Next one is 17, equals, and just keep pressing equals after each entry. So 29, 34, and 12. Now this is the counterintuitive step. So at this point here, what we're going to do is we're going to actually press AC to cancel all this away. Okay, so press AC, but don't worry, the calculator's stored all the information. Now we're going to press OPTN for option, then press 2 for one variable calc. So press option 2, and you have loads of different statistics here. So the one we're interested in this case is X bar, which you can see is 16.2. However, you can also see there's a breakdown of loads of other things which come massively in use later in the year when you might be talking about variance, standard deviation, and all sorts of other things. So this is particularly useful, not in this example necessarily, but later on. It'll even give you quartiles as well and medians. But as I'm trying to say here, the main thing is the mean is 16.2, which is what we knew earlier by doing it the long way. So moving on now to part D. Explain why a shirt manufacturer might use the mode when planning production numbers. So think about in real life what the mode represents and why it might be of use or of interest. Well, the mode is the most common. So shirts, unless you're naughty and you steal them, which I'd never condone, shirts are bought, which means shirts are sold. And so shirts make money, essentially, for a commodity. So the mode, because it's the most popular choice, that is likely going to represent the best seller. So the mode is likely to represent the best selling shirt. And so, I'll put actually has importance in terms of sales. So any shirt manufacturer is going to want to make sure that their best seller is in stock so they can make plenty of money for it. And that's all there is to do for worked example 2. Worked example 3 is very similar, although now instead of talking about just a simple frequency table with discrete data, we're talking about a continuous data set in a grouped frequency table. So this time we've got Bill, who's recorded the times in minutes, taken to complete his last 40 homeworks. So at least he's doing them, I suppose. The table below shows information about the times. Part A, we need to write down the modal class interval. So modal sounds like mode. It's very simple, just as a mode often is. So the mode just means the most popular value. So in this case, a modal class interval is just the class interval, which is one of these things, which has the most items inside it. So again, we go for the biggest frequency and read along. So the modal class interval is this one, 60 to t to 90. So all we need to do is just write this one down. For part B, we need to find the class interval in which the median lies. This is exactly the same idea as a previous worked example. So what I'm going to suggest we do, again, is a running total of cumulative frequencies. So the first one is 8. 8 plus 3 is 11. 11 plus 7 is 18. 18 plus 7 is 25. 25 plus 15 is 40. So median obviously just means the middle value. So the median is going to be the total number of values, add 1 to it and divide by 2, it'll be that numbered value. So 40 plus 1 is 41, divide by 2 is 20.5. So it's going to be halfway between the 20th and 21st. So it's very unlikely we'll need to consider this. All we need to know is find out where the 20th and 21st value would be. And we use the same idea as before. So we just look at these cumulative frequency numbers and we stop at the first value which exceeds 21. So let's do this now. So 8, it's not going to be that one, that's just the first 8 values. These first 2 intervals are going to be up to the 11th value, still too small. 18, so up to the third interval contains all of the first 18 values, which again isn't quite up to the 20th and 21st. But because this value is 25, that means the 19th, 20th, 21st, 22nd, 23rd, 24th, 25th are in here. So the median is going to be in this interval here. So therefore the median is in the interval from 40 to t to 60. Part C, we're asked to calculate an estimate for the mean time it took Bill to complete each homework. So now we're done with this cumulative frequency business, we can just clear all this off, like so, and focus on the business of doing an estimate for the mean time. Now, I'm hoping you might remember this from GCSE, but what we need are 2 extra columns. We need to consider the midpoints, and then we take the midpoints as an estimate for a typical time for each interval, and we do the midpoints multiplied by the frequency for each interval, each frequency value relates to. And so we need 2 extra columns ideally, like we've got here. So the midpoints, we just need to consider these carefully, and if we do that, we should be absolutely fine. So between 20 and 25, we just need the halfway point between these 2 values. So halfway between 20 and 25, that's 22.5. Halfway between 25 and 30, that's going to be 27.5. Halfway between 30 and 40 is 35. Between 40 and 60 is 50. And finally from 60 all the way up to 90, that's going to be 75. You then take each of these midpoints and multiply by the corresponding frequency. So this is where the calculator again comes in handy. So we get the class whiz, make sure it's in the normal mode, and the first one we do is 8 multiplied by 22.5. So 8 multiplied by 22.5, that gives us 180. So the first one we input is 180. The next one is 3 multiplied by 27.5. So 3 times 27.5 gives us 82.5. Then we need 7 multiplied by 35, so 7 times 35 gives us 245. And just for speed, I'm going to do these because I've worked these out already, although I can work out 7 times 50. 7 times 50 is 350. 15 times 75 you should find is 1125. Now what we're going to do is we're going to total up the frequency. So this one comes to 40. We're not going to total up the midpoints because that just gives us a nonsense. By the way, the frequency total was given here. It did say there were 40 homeworks. And the midpoint times the frequency, we also need to total these up as well. So adding all these values up, so the first one's 180, then plus 82.5, plus 245, plus 350, plus 1125. We get about 1982.5. So the mean, it's an estimate, so the mean is approximately going to be 1982.5 divided by 40. And so if we work this out and give it to the magical 3 significant figures accuracy, that gives us 49.6 minutes. So check if the answer is reasonable. Roughly 50 minutes for a homework. That's possible, that's realistic. Just make sure it's not a silly answer like 500 minutes per homework. Always check, if you can, if your answer makes some sense, and here it does. I'm going to show you how you could do this using a class whiz as well, like I did for the previous worked example. So on a class whiz, what we'd do is we'd press menu, we'd scroll along to statistics, press 6, and press 1 for a one variable calculation. So here, we need to make sure we've got the frequency column up, and if we don't, you'd press Shift, Menu, scroll down, press Statistics, and make sure frequency is turned on. So press 1 to make sure the frequency column is activated. So for X, we're going to input the midpoints. So 22.5, 27.5, 35, 50, and 75. Then we scroll up the frequency and input the frequencies. So first of all we have 8, 3, 7, 7, and 15. Then press AC, so clear it all off. Then press Option, OPTN. Then press 2 for one variable calculations. We're interested here in X bar, which is 49.5625. So again, like we got before, to 3 sig figs, this is 49.6. Part D is quite a common type question. Explain why it's an estimate and not the exact true mean. Well, we didn't actually know any exact values. So this interval here, for example, we didn't know if these 8 values were 21 minutes, 21.5, 24.7. We just took the midpoint as a typical estimate for all of them. So with a midpoint, we take this as a best guess, knowing that some will likely be above the midpoint and some will likely be below. But averaged out, the midpoint will be quite close to the true mean for the 8 items in this interval, you would imagine. So to put it simply, for part D, we just say something along the lines of the interval midpoints were used to estimate the actual times in each interval. And that will suffice to pick up that question. Normally be a 1 mark question this, but obviously it's 1 mark worth having, as they all are. So that's question 3 sorted out, which brings us now on to the final one, worked example 4. So here we are with worked example 4. So we've got the length x millimetres to the nearest millimetre of a random sample of pine cones which has been measured here. So the data is shown in the table below. Now importantly and crucially, we're told this has been given to the nearest millimetre. And also as well, if you have a look here, these class intervals do not run continuously from one onto the other. There should be no gaps between them. Whereas here you can see there's a gap between 31 and 32. In these cases, what we need to do is we need to make these class intervals continuous by considering the absolute minimum value of an item which would still fall into the interval, and also the absolute maximums, which is either where the class interval ends, or alternatively can be thought of as the boundary between where one class interval ends and the other one begins. So if we look here, the absolute minimum we could have, so it still falls into this interval, would be 29.5. 29.5 would round up to the nearest millimetre to 30. Then between 31 and 32, the cutoff would be halfway between these two, so the cutoff would be 31.5. Anything up to but not including 31.5 goes in here, anything 31.5 or over goes in this next one. Where this one ends is where this one would begin. Between 33 and 34, that's going to be 33.5. Between 36 and 37, that cutoff's 36.5. And finally, the absolute end of this would be 39.5, not 39.4 or 39.49 or 39.49999 recurring, but actually 39.5. Now many people think, well, if it were 39.5, sir, wouldn't that round up to 40? Well, yes, it would. What we're saying here, though, is this is the absolute limit, but not including it. Okay? So we can think of this as being this symbol here and strictly less than on the other side. Okay? So we can think of it as being these two symbols. So this is the absolute limit, but can't actually be this value. At any rate, we don't need this for part A, but this is a good practice to get into. So write down the modal class. So the modal class is just the class with the most frequency, which in this case is 30. So 30 occurs for 34 to 36, and so that's our modal class, because 30 is the highest frequency. Part B, estimate the mean. What we need here, like before, is 2 extra columns for midpoints and midpoint times frequency. So here we have it. Now to work out the midpoints, what we're going to do is we're going to average out these values in red for each row. Almost always, but not quite always, you get the same if you averaged out these. But sometimes these red ones will give different values. The key thing is, to find the midpoints, if you take the absolute limits, you'll always get the right answer. Whereas by taking these, you might sometimes get the right answer, but not always. For example, if this was from 0 to 5 millimeters, then the lower limit would be 0 because you can't have a negative length, and this one would be 5.5. So that would have given a different width than what we'd have by taking this one. So let's look at the midpoint. So what we're going to do is we're going to add these two together and then half. So 29.5 plus 31.5 would give us 61. Divide that by 2, we'd get 30.5. These two, add them together, we'd get 65. Half it gives us 32.5. Now these two, if we add these two together, what we get would be 70. 70 divided by 2 is 35. And finally, if we add these two together, what we'd get would be 76. 76 divided by 2 would be 38. We then multiply these frequencies by the corresponding midpoints and see what we get for each one. So, first of all, 2 times 30.5 is 61. Next one, 25 multiplied by 32.5. So 25 first times 32.5. That should give us 812.5. And 30 multiplied by 35. It's always worth doing that on a calculator, even if you think it's 1050. Calculator will be a friend for A level. So 1050. And finally, 13 multiplied by 38. Just multiply these two and we're done. Well, almost done. 13 times 38. That's going to give us 494. And so if we total up these values, so the total of these, 2 plus 25 plus 30 plus 13, that should come to 70. We don't total the midpoints, but we do total these. So 494 plus 1050 plus 812.5 plus 61. That gives us a grand total of 2417.5. I'll put a little just squiggle over there because that looks like a times sign, which is not what we're doing. So here, the mean, it gets in a red pen actually. So the mean's going to be 2417.5, I mean to say, divided by 70. And that's going to give us to 3 sig figs 34.5 millimeters. Finally, for part C, the class interval which contains the median, we need to work out which one the median would be. There's 70 items. So, for median, is going to be the mean of the 35th and 36th value. Remember, do 70 plus 1 and then divide by 2, we could get 35.5, which we interpret as the mean of 35 and 36, because 35.5 is between these two. So now what we need to do is this cumulative frequency idea. So we do a running total of these frequencies. So first one is 2. 2 plus 25 is 27. 27 plus 30 is 57. 57 plus 13 is 70. And we stop and read off at the first value that exceeds 36. 2 is too small. 27 is too small. 57 is the first one that exceeds 36. And so, therefore, the median must be in this one which has 57 as the cumulative frequency. So read along. it's this interval here, from 34 to 36. So therefore the median is in the interval from 34 to 36 millimeters. And that's all of them finished. So now, over to you. If you could try these for me, so page 22, exercise 2A, have a go at questions 1, 2, 3, 5 and 7. Then once you've done those, a bit more study for you here, from page 24 to 25, exercise 2B, try and rattle off all these questions. This is revision from GCSE, so on one hand you might be thinking, why do you need to do it? You've done it before. But the way I'm looking at it is, because it's GCSE, you need to absolutely have this knowledge completely watertight if you've got any chance of grasping the harder concepts later on. So you need to be absolutely solid on these. So do this, treat it as crucial revision, and get back to me, as ever, if there are any problems. Thanks for listening once again. Remember to subscribe if you can, and I'll see you all soon. Thanks for listening, and bye for now.